Okay. So mathematical definition of continuity. Yes, Chazzy. I feel like I asked a question, then you asked a different question. Sophia.
As x approaches a, the limit of f of x is equal to f of x.
Okay, so limit as x approaches a of f of x is equal to f of a, and this is what it comes down to. And Chazzy, I will go over one of the homework questions at least. Probably the first one, namely. I'll start with that, just to kind of connect these. Now, last time we talked about, along with continuity, a place where the lines don't touch is a place that's called discontinuous, right? There are discontinuities. How many different discontinuities are there? There are 3 discontinuities. I'd like you to go ahead and discuss with your neighbor, what are they and how do they relate to the limits? Okay, so I'd like to hear one of the type of discontinuity and how it kind of fails the continuity idea in terms of limits. Henry, can you tell us one of them?
One would be, discontinuity.
Okay,
And that one, fails is as x of perfect, what would be like, a critical asymptote. It goes to, oh yeah, it goes to y or f of x equal to, equals literally on one side and then, a doesn't have a value, right?
right, exactly. F of 8 doesn't have a value. Okay, thank you. So the infinite discontinuities, there are 2 different parts of it. So first of all, on the left side, the limit is going to go to either positive or negative infinity. And like you said, for the right side, there just is no f of a. In place is just a vertical asymptote. So it kind of fails it 2 different ways. So that's infinite discontinuity. Let me put this up here. So this is just a summary of what we talked about last time. Continuities. Did I spell that right at all? Discontinuities. Okay. There's infinite discontinuities. Thank you, Henry. Another one. Yes, Karen. Okay. Okay, and what's happening at f of a? Are we good? So in this case, our a would be here, that limit, in this case, that limit does exist, but it's not equal to f of a. So it can either look like that or yeah, somewhere not there, either above it or below it, just not where it seems to be headed for that limit. Brianna? Any final comments on this or? Okay, so jump as well. Nice. Well, actually, but before, let me see everyone's interpretation. Would you show me just in front of you what that would look like? Just jump discontinuity. What would that look like? You have one piece of the function with your left and one piece with the other hand. Yeah, so it's just like going, not like this would be removable through the hole there, but like this, I think this is what you're talking about. Yeah, okay, so. If my A is over here, then I have something like this going on up there. And then this, so that was jump. And how does this fail the limits issue?
Then the limited after that is not, I think it's in terms of left. Really that's about to not the way, and well, I think it's very, really rather than.
Yeah, that-
They approach it in the.
Okay, perfect. And so what would we say about that limit? When I go to different places, that remember that the limit does not exist, so it fails that the criteria for being continuous. At that point, every other point, it appears to be continuous, but at that point, it's discontinuous. It's a point of discontinuity. Do those ideas make sense? Okay, so back to the packet. When we did this one, if I'm just dealing with the discontinuity at x equals 0, does that make sense that I'm checking 0 for discontinuity? Specifically, I'm checking there for a jump discontinuity. Otherwise, and the other ones, since they're rational functions, they would be either removable or vertical asymptotes, so the infinite discontinuity. So if I'm checking for a jump discontinuity, I think I'm just starting this over again. Is there a jump discontinuity? I'd be checking to see if the limit as x approaches 0 from the left is equal to the limit as x approaches 0 from the right. Yes, just checking for a jump right here. And to check that, yeah, we find the limits. Just check with your neighbor. How do you find the limit of each side there? Like, I'm just trying to do this little portion right here. And which one's easier to evaluate? One from the left or from the right? They're both pretty easy. And some may say, wait a minute, okay, so if I want to check this one that's coming from the right, all I have to do is plug in 0. So I would get -2. But on the left side, x is less than 0. How do I check that limit as x approaches 0 from the left? Plug in 0 again. We don't need to plug in a tiny little number. You plug in 0 and just understand that when you graph it, that would result in open circle, a hole. So when I plug that in, on the left side, you're left with -4, and since these are not equal to one another, it's a jump discontinuity there, which we already talked about last time. That's why it's here. And we graphed it, so you can see that graphically, definitely a jump discontinuity. But you don't have to graph it to tell that it's a jump discontinuity. You just check at that space. So then when you get to your homework, you have this problem. And again, we're going to check to see what happens when x equals 0. So we'll check from the left, the limit as x goes to 0 from the left of this function. And see what happens as x approaches 0 from the right, and see if these are equal to each other. Or it's actually saying to find a non-zero value for the constant k that makes it continuous. So we want these to be equal to one another. I can give you a moment to talk about this one. Can you call on someone about 20 seconds, help us out, maybe 10 seconds, you have some time to talk already. Okay. Sabrina, the opposite this week. So you didn't want to just plug in a zero? Okay, so you broke this up into sine of kx over x times cosine kx. What do we think about that? Are we okay? You can't plug in the zero directly like we did last time, so we got to see what we can do. So we're just left with, okay. Are we good with that so far? Yeah, the left side, how about the right side? Okay. Nice, so we have 2k squared equals k. K equals what? How'd you get that? You did, okay. You divide by k, so you get 2k equals, oh, k equals 1/2. Are we good? Any questions? Thank you, Sabrina. I do want to warn you about it here. Be careful about dividing by a variable. Instead, I recommend, what's that? Leave it be, yes. So what's the other option? Oh, ZPP? I thought I said leave it be. But okay, that's true. That's very kind of you. And of course, before ZPP, we're gonna have to subtract k from both sides. Yep. Subtract k from both sides, exactly. And then, can we use ZPP now? We can't use ZPP unless it's a product, so we have to factor it. That's what factor out the k. 2k minus 1 equals 0. Sabrina, has this been helpful? To do it this way, has this been helpful at all? Did we get something different? Nola? I'll answer your question. Let me finish with this. Let's do the ZPP. We get k equals 0 and 1/2. So is there another solution? Could k be equal to 0? It does say find a non-zero value. So we found it, but doesn't even want it. But do be careful about dividing by variables or variable expressions. We're going to be losing solutions when you do that. Unfortunately, or fortunately, I guess, the solution we lost, we didn't want it anyway. We should have just left it be. Left it be. Let it be. I don't know. No, I think you had a question. Could someone help us with that one? Because I forgot. How does that become, yeah, what happened with that sign? Brandon? But why does that get rid of anything? So you're saying like, if I do a sign of, let's say AX and AX here, is this equal to 1? Are we good with that being equal to 1? We have to make sure that we're taking the limit as X approaches 0. It doesn't automatically equal 1. That's when you take the limit as X approaches 0. How do we know that? What's that? Exactly, that's one of the 2 rules, the 2 trig rules that you need to know. So there's nothing that involves tangent, but you notice that tangent is sine over cosine, so we break that up. Just make it happen, like you did. Thank you. Karen.
Provide that rule that you did in the bubble, like, let's say on the text and it's.
Oh, no, you can reference it just in your own head. Your literal thought bubble. Yes. What's cosine of 0? Yeah, so it's just about, at that point, good point. Thank you for helping us close all of these doors. You're just plugging in 0 there. Limit as X goes to 0. All the right, we want it to be continuous, so we're just checking to see what happens here. It's not continuous everywhere, but at X is going to be there. This is continuous everywhere. This is just, you know, it's not bad. Right? It's a line, isn't it? It's like, there's 3 now, why is that so? 2 takes straight. It's definitely a line. This is function of X. 3X plus some sort of constant. Do that one more time? Oh, good question. Yeah, if this is going to 5, not even just plugging the 5. The problem here was that when you plug in a 0, verification, you have to take limits as X goes to 0. Yeah. Okay. If you have other questions about the homework, I'm happy to help you out one-on-one, or maybe to, you know, at the end of class after we finish the rest of today's lesson. Today's lesson, by the way, is our penultimate lesson. Yeah, I know. For this entire year. We have a quiz next time. I think we have a review sometime. That's it on Thursday. Yeah, something to look forward to. Yeah. So I'm gonna introduce this with the walk down memory lane. So go ahead and put your pencils down, sit back, relax, and enjoy a tale of one of your days in pre-algebra. Or maybe algebra 1. And I don't know who your algebra 1 teacher was. But I know they were stellar. Is this true? Did you get extra credit for doing that? He did all that, didn't even get extra credit. Just another day, the life of a 7th grader. Anyway, That's a tangent you took me on. What? What? I don't know what you're talking about. And back to pre-algebra. There's probably some time when you were given 2 points and the teacher said, I want you to find the slope of the line that goes through 2 points, and you said, I can do that. Yeah, up such and such, over such and such. Maybe you did something like, oh, I know m equals y 2 minus y1, x2 minus x1, yay, and you got the slope of that line, and you were happy, and you got an A with a day, I don't know.
Yeah.
I know you got an A. Possibly. Maybe, I'll look through my records. Okay, so today we're gonna do the same thing except and take away one of the points. And then find the slope of the line just going through 1 point. Which might leave you with a question. What? How can you do that to us? Because if you look at this, and I tell you, imagine the line that's going through that point. You're all probably imagining different lines, but each one of you is probably imagining 1,000 possible lines going through that point, correct? So don't worry, there's more guidance. But yeah, today what we're gonna do is find the slope of a line going through a single point. You ready for that? That's the motivation for today. Let's go to the packet. Yeah, packet's right there. Look that you can tell the future.
Yeah, there you go.
Yeah. In geometry, you remember what tangent lines are, don't you? From that class?
Yeah.
What does the word tangent mean? Like, anyone who's speaking Latin, does anyone know what it means? Touch, yeah. So I hope it makes sense that a tangent line just touches the circle at one point. That point is called the point of tangency, or the tangent point. Okay, we're going to take that, and instead of talking about circles, we're going to talk about tangents to curves. So like these 2 lines here, they cross through at one point, but they are not tangent lines. Tangent line would be more like this, if we're looking for a line that's tangent at the point P. Does that make sense, that that's the idea that we're talking about here? Even though that line actually crosses through the function, in this case, at 2 different points, where our world is right here, right now. So we're talking about it, this line is said to be tangent to this function at point P. So we're going to look learning today about how to find the slope of this tangent line with 1 point. But notice, it's not just like a random line that's floating through space. It's a line that is tangent to this function. And we do this, and this is just brilliant. Like whoever developed this is incredible. This is actually an animation. And we have point P, which is the point of tangency. And then take a look at point Q. The line going through point P and Q is called what kind of a line? Not a tangent line, it is a secant line. Does that make sense? That's a secant? Oh, good question. So do we agree that it's easy to find the slope of a secant line through P and Q? But let's take that Q and move it along the curve such that it approaches point P. Now, this should be an animation in your head. Do you see what's going to happen to the slope of that line as that point Q approaches point P? It's going to get closer and closer to the slope of the tangent line. Does that make sense? In fact, if we were just like 0.0001 away, wouldn't that be pretty much the same as the slope of the tangent line? So we're going to use that idea. And what idea is that we've been discussed recently that we're going to be talking about? Limit. It's a limit, isn't it? Where Q is approaching P. Let's see how we're going to do that. You see the animation though? It's not just a diagram, it's an animation, you should see it like. Etc. You could actually see the animation, huh? I should have made that happen today. Nice. Let's see if I could find that for next time. But more powerful than Desmos. Your brain. Your imagination. Even though your imagination might be a little bit more scary than Desmos. More powerful too. Okay, so slope of a secant line. There are 3 different tales we're going to tell about the same story. For a general function f of x, find the slope of a secant line to the function f of x between the points with x coordinates a and b. What is a familiar name we've used to refer to this expression in the past? Okay, well, for a, if the x coordinate is a, then the y coordinate is f of a. This is what I want to on my speaker. What have we done? And b, comma, f of b, yeah. We now have 2 points on this function. We could find the slope of the line going through there. Slope is equal to f of b minus f of a over b minus a. So what is a familiar name we've used to refer to this expression in the past? Is it something? Slope. Slope of a secant line, slope of a line, I don't know. Here's another one. Here we have x coordinates there. X, so that means it's x comma f of x and x plus h comma f of x plus h. Would you please write the slope of the line going through those 2 points? Did you get it? Joanna, can you tell us what you got for the slope there, please? Oops, just over h, you said? Is that true? Everyone is just over h? Yeah. Nicely done. Thank you very much. And the last one, find a formula for m underscore secant, or the slope of the secant line, the slope of the secant line to the function f of x between the points with x coordinates c and x. So we got c comma f of c. I'll let you finish this. I'm gonna ask for one more person to help us with this. You get it? Rana, what'd you get?
That's like steps.
C over x minus c. Are we good? Thank you, Rihanna. Now it keeps asking the question, what's the familiar name we have used to refer to this expression? You know what it's referring to? Because I think you may have seen it in different forms. No? Yeah. It is average rate of change. Very nice. That's one way we refer to it. Another way is the difference quotient, which you see pop up regularly in this class. Okay, the equation of a tangent line. So what's happening here is the slope of the secant line, and then we're taking that, and as we said, we're going to move x to c. And that will give us the slope of the tangent line.
Well,
What's that?
like if you're moving X towards C, then wouldn't that just be the,
But it's not C itself, it's really close, right?
so it would just be getting really close to zero.
Well, let's do a problem and see how this goes. We're looking for the equation of the tangent line to the graph of f of x equals x squared at x equals 1. So I'm going to start with a diagram of the function. Here's my 1. Could you visualize the line that is being referred to? You all visualize the same line? Show me with your arm what that line looks like. Nice, I'm seeing it. So it looks something like this. Yeah. Okay, in order to do this one, I need 2 points really to find a slope. I need 2 points. So I'm going to choose x comma. What's the y value for this? F of x, which in this case is x squared, isn't it? It's not just a general f of x, it's for sure it's x squared. So again, can you imagine the animation in your head? Maybe we start with the secant line here. Then you move that second one until it becomes that tangent line. I think that's the first time I used that ruler function. That was nice. Let's see if we can find the slope of this tangent line.
So,
So people might be really confused right now. So maybe talk it out, see where you're starting. Make sure you have a direction to head.
like that.
Isn't that?
Did you get something?
Yes.
Where are we starting with this? Hey, Karen.
I did x squared minus 1 over x minus 1.
Does this make sense to set this?
Yeah.
I have 2 coordinates. I forgot to label the coordinates here, but this is 1 comma 1, isn't it? So that's the slope of the secant line. So we're going to take the slope of the secant line and then take the limit as x approaches 1. Like literally this x value is approaching 1. Let's see if we can figure that out. Karen, thank you, by the way. Chaz, do you have a question or an answer?
I have a question.
What's your question?
Why, like for the, in the formula, it says that it's the limit of as X, Y approaches P. But why is it now just X approaches P?
Good question. These are 2 different things. So what it's saying is that we're taking the limit of the slope from X to. So this here is XY. And that point is approaching P. And this point here is P. So it's just this is perfect.
Oh, so just add that.
Yeah.
We're only talking.
I think that's a little bit unnecessary here. The slope of the tangent line here is this. Yeah, I think this is what we're.
Yes, yeah.
Specifically. Good question. Show me what you got. If I'm seeing correctly, I think we may have the right answer. Nola, can you talk us through what you did here for this one, please?
Actually, well, I'm not 100% sure what that's.
Well, did you try to plug in one to top and bottom? And what happened there?
It makes the bottom zeros.
How about the top? Yeah, when you have 0/0, what was that called? Anyone remember? Indeterminate, so we got to mess with it a little bit. What can we do with the top? So how did you rewrite it?
I kind of forget. Right.
There was a square, let's see,
Oh, wait, X plus 1, X
x plus 1, x minus 1. So the bottom, I think, stays the same. Okay, and now what?
then it was
Now I can plug in one? Or do I have to do something first?
maybe cancel out that.
Yes, we remove that. So we get 1 plus 1, is that what it is?
Yeah.
Are we good? What kind of discontinuity did we have here? It's removable. Now, there's no removable discontinuity in the function itself, but this is our new unseen function that definitely has a discontinuity at x equals 1. We removed it and we were able to find the slope of the tangent line. The slope is 2. Does it make sense that the slope is positive? Perfect sense, doesn't it? Could have got to a negative number, there would have been something wrong. Unless you're finding the slope of the tangent line at x equals any negative number, really. What do you think? X equals any negative number would have resulted in that negative slope. Any questions? Yes. Oh, it's asking for the equation. Let's finish the question. Thank you. Right, so let's see, we have a point, we have a slope, the form that would be probably the most accessible to do. Point slope. Would you please write your answer in point slope form? See if your neighbor remembers how to do that.
One y minus was equal to 2 times x.
Yeah. Who'd like to tell us what it is? Yes, no.
Times X minus.
Are you good with that? And from there, just leave it. Unless it asks for it in slope and SF form. Yes, thank you for reminding us to finish answering the question. It's easy to forget about that when you know you've done all the heavy lifting. It's just light work. Okay, definition. If y equals f of x is a function of c, and c is sorry, if y equals f of x is a function and c is in the domain of f, we define the derivative at c, noted by f prime of c is a number f prime of c equals all that limit. So when you see f prime, well, when you see that expression with an apostrophe, that is read f prime of c, and by definition, that means the derivative of f at value c, which means we're looking for the slope of the tangent line at or when x equals c. All these things come together. So we just look at the secant line, slope of the secant line, and then take the limit as x approaches c. So if we're looking for the derivative of this, should we graph this function? We're going to graph it. Let's see if we can already make it happen. For the derivative, we're looking for f prime of 2. Check in with your neighbor, make sure that they're getting some. When you did it. Thank you.
Oh, I was, yeah,
Minus. Here's the very- Oh, it's still there. Oh.
I do want to call on someone just a few seconds, so make sure that you have something to start with. You ready? Ready or not? Brandon, can you help us with this, please?
So it would F on to equals of X and approaches.
So far, so good.
And so then from there, I'm a little lost. I can try. I think I put like 2x squared minus 5x all the time.
I'm even gonna take you back because some people may be super lost and what you said is correct, but let's just keep going by this. Let's just say f of x minus f of
C, or two.
2 over x minus 2. Are we good with that so far? Okay, now Brandon, you had taken a step farther and I appreciate that. So please continue with what you were saying. So you said x approaches 2.
I put for f of x, I put a 2x squared minus 5x.
Okay,
So I guess then the minus f of 2, or I don't know what.
well, we have to figure out what f of 2 is, right? That's what's telling us. So how do you figure out what f of 2 is? Plug it in. So we get 2 times 2 squared.
Oh, so that's like -2.
Is it -2? Okay, so this is -2, which means I say minus -2. Plus 2 on the top, and on the bottom is x minus 2. Brandon, what do you think the next step is? Because if we plug in a 2, we're getting 0 over 0.
Oh, factor.
Probably factor. And what do you think one of the factors is going to be?
X minus 2.
Hopefully x minus 2, don't you think? And every time that will work out, which is kind of magical. So let's see. On the top, we have x minus 2. We're hoping. Now we will check just to make sure. If the first factor is x minus 2, that means the other factor is 2x minus 1. Is that right? Let me just check to make sure that that's right. So these multiply. I see the plus 2. Is there a minus 5x on top?
Yeah.
Okay, so this is good. So has this helped?
Yeah.
What's our answer? Is that true? Answer is 3?
What is 3? Like, is that like the slope? What is
Good question.
derivative?
Good question. Well, according to Brandon, it's the derivative.
What's the derivative?
Would you please discuss with neighbor? What did you just find here? What does that 3 represent?
I thought that's what we just saw. Wait, so what was 2 on the problem?
Yeah, no.
Okay, I'm not entirely sure how you set up this problem, like with the. How do you know like F, you're searching for F minus 2?
Huh?
Like,
Well, it says find the derivative at x equals 2. So, and we just now learned this, right? This is the first thing, so it takes some time to sink in. So I'm just trying to digest that blurb there. So this means the derivative at c.
Mhm.
So when it's looking for the derivative of this function, that is f prime of 2.
And
What does that mean, the derivative? Slope of the tangent line at x equals 2.
C is 2.
C is 2, yes.
Okay, but it's given to us as X.
It's an x value. Right, so like in the last problem that we did, in this case, C was 1, and we found f prime of 1. But we didn't call it a derivative, we call it the slope of a tangent line. But derivative, slope of a tangent line, exactly the same thing as a special kind of rate of change. It's not average rate of change, but
difference push.
instantaneous rate of change. You're gonna hear that too. Chazzy.
Wait, so is C the same thing as P or is it?
Yeah, C,
Value?
C is the X value of P. I think that's what I was saying in here too, right? Thank you for helping connect that. Yeah, so P is the point on the graph, C is the X coordinate of that. Yeah, good questions. And the C doesn't move. C is constant. It's the X that moves towards the C. So the answer for example 2 was 2. The answer for example 3 was 3.
Example 4 is 4.
I wonder what's going to happen with example 4. Why don't you try it? Try examples 4 and 5. Well, let's do one at a time. It's just example 4.
When I ask for derivatives,
What you get?
It's asking for the slope of the tangent line.
it's like it before.
Brandon, thank you for your help with that last one, by the way. A couple of algebraic fuzzy spots here. Make sure that your neighbor is doing okay with this, please. When you get to a comfortable stopping point. And if you're confused about even where to start, definitely check in with your neighbor.
No, I get it.
Next one.
I get it. Getting rid of all these things, all. X times the. I just looked what I was saying. You got it? Got it. I got one.
Wait, hold on, next.
I don't think zero is usually. Here, here's what I did. Here's what I did. Multiply by, I can take one down, multiply by, multiply by, cancels out. I think
And then.
If you can't be done. Does anyone already finish example 4?
I swear.
Go to 5 is delayed. I want to talk about this in about 30 seconds, though. I will be calling on one helper.
You're putting your own number. Fine.
Well, I would, okay, that's cool.
You're putting your own.
In the front.
I tried multiplying by the denominator, but
Yeah.
the bottom didn't resolve that thing, so. I don't have any other idea. Because if you still plug in 7 in the bottom, it gets you 0. So you got one.
Yeah.
Okay, so I'd like to get some help. Now, Joanna, you already answered something today, but it was kind of short. Do you want to help us with this, or do you want to try to move on to someone else? It's completely up to you. You sure? Okay, you're very kind. Brianna, I feel the same. Like I feel like your answer was super short. So do you want to help us with this one, or do you want to? Should I call on someone else?
I don't know if I played it correctly, but I can. I mean, I don't.
Okay. You're in a safe place. So let's see what you were thinking here.
So the first thing I did was I started with points,
With what?
points of. Like we did the other ones were x and -1 over x, and then 1 and -1.
Okay, so you have x comma -1 over x and 1 comma -1, you said?
Yeah.
Does this seem like a good place to start? I think I like what you're doing. Let's do. Yeah,
You
here.
combine the x of f of x and x equals 1
Limit.
of -1 over x.
Well, what are you gonna do with all these points? What are you gonna do with that? We find the slope of the, yeah, exactly. So what's the slope of that line?
Okay, so I started with -1 over x minus 1.
Minus,
Minus, oh yeah, -1.
minus
Minus
-1, which becomes +1
and
over.
then over 1 minus x.
Be careful, if you're gonna say -1 over x minus -1, you have to go the same way, so. Right, if you're saying
Oh, sorry.
this minus this, it's gotta be the same thing, x minus 1, which I think will possibly help.
Yeah.
With your work here.
Minus 1.
Okay. Now, this is, of course, the slope of the, what kind of line is this? It's not tangent, the slope of a secant line. This is 2 points.
Like x minus 7.
We want to make it the slope of a tangent line by doing what, Rihanna? Taking the limit as
X approaches.
x approaches 1. Are we good with this? So it leaves a little bit of an algebraic mess, doesn't it?
Yeah, because if you put 1 is divided by 0.
Yeah, it's not only is divided by 0, it's also 0 is on top, isn't it? If you plug in 1, you get 0 over 0. Indeterminate, so there's got to be a way out of this. Are you okay continuing?
I don't think I did it correctly.
Okay, so do you want to pass it off?
Yeah, I think someone else.
Okay, Miles, can you help out with this, please?
Afterward, you can multiply both top and bottom by x over x.
Why would you do that?
Get rid of it.
Yeah, it's just unpleasant, isn't it? And when you do that, you're left with. So on top, you just have x minus 1, is that right? Does he speak the truth?
Yes.
Over x times x minus 1. Okay, then what happens?
You cross
Oh, yeah, I like the same. Okay,
get 1 over x, and plug in 1, so it's 1.
so it's just equal to 1. Any questions about this? Nicely done. Will you please discuss with your neighbor, first of all, anything you need to work out, but also, why does 1 make sense for this problem as an answer? So not work out any bugs. And why does 1 make sense? It should make perfect sense. Here you're looking at the right thing.
One big set.
I think that's one.
Like, let him.
Yeah. Yeah, miles.
Okay, so why does it make sense?
I think 4, 6, 8.
Why does it make sense?
Oh.
Because it does. Thank you.
Yeah.
Do we know what this function looks like? It's in quadrants 2 and 4, and it kind of looks like this, doesn't it? Did someone say 2 and 5?
He said 1 and 3.
He said 1 and 5.
That would be quite incorrect.
Let's start with 1 and 3, and then switch to 2 and 4 because of the transformation. Okay, so, and why does it make sense then that the answer is +1?
Because it's like going up.
It's going up. We know at this point right here, and it even looks like it would have a slope of tangent. The slope would be 1. But where did it even say that we're supposed to find the slope of the tangent line? It was just like f'(1). Where does it talk about the slope of a tangent line? Yeah, when we're talking about derivative, that is the slope of a tangent line. Find that, as Rihanna did, you start with the slope of a secant line, then take the limit as that x goes to whatever point we're headed towards. Thank you both for your tag teaming that problem. Example 5. Has anyone finished example 5 yet?
I'm stuck.
Yeah, I'm stuck too. I'm not sure. Might not
Work harder. Get some help from people around you. You could do this.
Multiply by X.
So I was thinking like still like X minus 1.
No, you have to multiply by.
Yeah, because I think maybe you substitute like a variable for the string. That's still big. Yeah, but it's still not solved. I know, that's too very. Don't you just multiply by root X minus 2? Definitely, that's the only way you can do it.
That's why 2 minus 1.
No, actually. I did. That's not the. Oh, you don't. You know.
Very flip on.
X minus 7.
You getting anything?
Brandon has something. Yeah, exactly. Something has come to.
Surprised.
Okay.
Oh my god.
Did he use the word a foot?
A foot.
Minus +3, yeah.
Yes.
Someone needs to bring that word back.
I just
Karen.
brought it back.
It's Karen, yes.
Yeah.
You ready? Are you ready or not?
Oh god.
We'll work through it together. Quinn, can you help me with this one, please? I'd like the only voice I hear to be Quinn's, please.
So I set it up as square root of x plus 2 as my f of x. And then minus f of c, I consulted my partner here, Andrew, because I plugged in x as 7 for the equation, and I wasn't sure if the square root of 9 was equal to 3 or plus or minus 3.
Ah, good question.
Said that because the square root is defined as positive in this equation, that we can assume that it's positive. So then I just did minus 3.
So you're taking your partner's word for it?
Yeah, what?
I wasn't sure.
I don't know. What?
Is it true that the square root of 9 is 3 as given?
Teacher, I guess.
Is it true that this is just positive 3?
Yeah.
Really?
I mean,
That would be good.
that's what it is.
It's a function. Could there be 2 outputs?
Pause.
It's positive.
How it works is.
Is it positive?
Yes.
Yeah, it's positive. just positive 3.
There was a false problem on it earlier this year, that's how I know.
So you learn.
that problem.
Okay. And let's talk about that a little bit later, but I would like to get the rest of this from Quinn.
Then square root of x plus 2 minus 3 over x minus 7. That's where I am now.
Okay, so far we have the slope of the, what kind of line?
That's a secant
It's a secant line, so we want to make it a tangent by doing what?
by finding limit of purchase tangent.
Good, so we have this, so why don't we just plug in a 7? Because then it's indeterminate, so any idea what trick we could use to get out of that determinate stuff here?
How do you get?
Okay, we'll rationalize numerator. Alright, so what I'm hearing is amazing. What I'm hearing is conjugates. Yes, Brandon, you have a question or you want to continue?
Let me continue.
Would you mind?
Well, sure.
Okay,
Alright. So you multiply by the square root of x plus 2 plus 3. Right?
okay,
On both sides, right?
okay,
And that turns the top into x minus 7.
so x plus 2 minus 9 first, right?
Yeah, exactly.
What should I do at the bottom?
Leave it.
Oh, okay, just, I don't have to distribute,
What?
okay.
And
Okay,
then the top is x minus 7.
just x minus 7, is that what it works out to be? That's nice, okay,
And then you cancel, then you get 1 over square root of x plus 2. Plus-
1 over that,
Yeah.
cool.
And then you plug in 7, and you get 1/6.
We get 1/6, is this true? Nicely done. But thank you for letting Brandon continue with that, that's very generous. Any questions? I have a question for you. Please discuss with the neighbor, why does that 1/6 make sense?
I mean, the square root graph.
Square root graph looks like this.
Yeah. Shallow, just like a slope. Yeah.
Oh, yeah.
Quite a shallow. Like,
So why does it make sense? Like perfect sense, really? Why?
I think Brandon.
Because the math gods told us so? Because Brandon said it was such, yes,
Like square root graph, like as it approaches 7, it's already like kind of starting to like flatten out. So.
of course, the square root graph has been moved to the
Left.
left too, right? Okay, so doing this kind of thing.
Not really like a kind of a flatter slope. Not sure.
Are we good with that? And of course, the slope is positive, but like you're saying, it's kind of flatter, so it's really 1/6, very close to 0. Yes, Sabrina? Say that again. Oh, thank you, yeah. From the graph, we can see that that square root of 9 gives us just that positive 3. Yes, Miles?
So without drawing the graph,
Huh?
let's say you didn't draw the graph, right? And then you have 1 over root x plus 2 plus 3.
Mhm.
Would you know that it's positive 3? Because if it is negative, because you like the square root would be plus or minus, right? So but you would disregard the minus because it would give you 1 over 0. Is that why we're disregarding?
That's a good way to say that would be bad if we made it -3. And then you have to like rationalize the denominator, then the top, that it would just be a game of ping pong. But really what it comes down to is that this, by definition, is a positive square root. So if if you're solving x squared equals 9, then yes, I want both square roots. I want both plus or minus. I want x equals plus or minus square root of 9. But when you just see that positive, I just want 3. If I ask for the negative square root of 9, and this is universal in all math classes, negative square root of 9, That's -3. If I want both of them, I'll do this. So if you see that without a sign, it's called the principal square root, and it's like for the positive, so there's no ambiguity at all. So, thank you for asking. Because it's like when you're conscientious, you think there should be two, but really there's only one. Have we finished the question?
No.
We have not. There's a whole lot more work that needs to be done for this one, isn't there? Check with the neighbor, make sure that they have the right answer for the equation of the tangent line.
You have to go. Have 7.
Use like-
only marks. Yeah,
So it's like water slide of it.
Plug it in. Yeah.
Okay, so the equation of the tangent line, Miles, can you help us out with that one? The equation of the tangent line, we have a slope.
So, because you have a point, that's so you can do points up one, so it's y minus 3 equal to 1/6 x minus 7.
Does he speak the truth? Accidentally, I left -7. X minus 7. Any questions? Hope you enjoyed this look into calculus. This is really the first semester of calculus. This is what we're going to be talking about all the first few months of school next year. So you have some to look forward to. You have some time to work on your assignment. So take a look at it, see what you can do.